Assalamualaikum and hi, we are from group 4. So in this video we will present about steel truss design of stadium basketball. So this is our group member, Khairunisa binti Khairi Anwar, Khairunisa binti Mustafa, Nur Maizatul Husna binti Zulkifli, Nurul Nadia binti Majuso, Elias Muhammad Yusuf.
I'm going to explain manual calculation for this truss. Firstly, we find the length of principal, then half plane area and half slope area to get the preliminary calculation. Then we find the dead load to get the load for each member of the truss. So this figure shows the load of truss. Then from this, we find direction A and B. This figure shows of internal forces that get from using method of joint. Calculation shows of tension member 250 or 197. Firstly, NED we use value from step pro, which is 11.624 kilonewton. Then from this we find the area to choose the cross sectional. Then we use size of UB 100 to 76 and 30. From sectional classification, we find overall classes of this section is a class 1. We move on to the verification. Value of NPLRD bigger than value of NED, so it's okay. Also value of NURD also bigger than NED, so it's okay also. Then we choose the less value from this calculation for NTRD. NED divided the NTRD was less than 1, which is we got 0.03, so this member is okay for tension.
For the next tension member, which is 183, 186, 204 and 201, the NED from the stat pro analysis is 27.173 kilonewton. From the calculated area, we can determine the suitable size of beam, which is 127 times 76 times 13. Then we do the sectional classification, and both flange and web we got class 1. Next, for the verification, both NPLRD and NURD is okay. So we choose the less one, which is NPLRD, to become NTRD. NED divide with NTRD, and then we got 0.06, which is less than 1, so it is okay.
I want to explain tension member at 187, 188, 205 and 206. From step pro analysis, we got NED value is 39.429 kilonewton. By using clause 6.2.3, NED over NTRD must less than 1. By using formula NED equal to AFI over gamma M0, we can get the area value, which is the value is 143.38 millimeter square. So we decide to use 1277613 with area 1650 millimeter for column. For sectional classification, the value of CW over TW must less than 30.4 and the value is 24.2. CF over TF must less than 12.9. Value is 3.74. Class for section is class 1. Verification. NPLRD value is bigger than NED value, which is NPLRD value is 453.73 kilonewton, and it's okay. NURD value must bigger than NED value also. The value of NURD is 638.55 kilometer, which is bigger than 39.429 kilonewton. After calculation, the value of NED over NTRD is less than 1, which is 0.08. It is okay.
Next is tension member 199. From the stat pro analysis, the NED value is 7.765 kilonewton. Next, NED over NCRD must lesser than 1.0. From the formula, we can get the value of cross-sectional area, which is 28.24 millimeter square, and we use the size of UB, which is 127 times 76 times 13, and the area is 1650 millimeter square. Next, the value of sectional classification is calculated, which is 0.92. Then from that, we calculate the value of CW over T. We get 30.36, which is bigger than 24.2. Therefore, overall class of the class section is class 1. Next is verification. As for NPLRD, the value is 453.75 kN, which is bigger than 7.765, and it is accepted. Next is for NURD, the value is 638.55 kN, which is bigger than 7.765 kN, which is accepted. As the value of NPLRD is equal to AFY over gamma M, hence the value of NTRD is equal to 453.75 kN. By using the formula of NED over NTRD, we get the value of 0.02, which is lesser than 1, then it is okay.
Calculation shows compression member 198 or 216. Firstly, NED we use value from step row, which is 29.2723 kN. Then from this we find the area to choose the cross sectional. Then we use size of UB 127.76.13. From the sectional classification, we find overall classes of this section is a class 1. For compression calculation, we get the value of NCRD is bigger than NED, means okay. Then we find the buckling resistance of the member for in plane and also out plane. For in plane, we find the NED divide the NBZRD less than 1, which is 0.69. That means it's a satisfactory. For out plane, we find the NED divide the NBZRD less than 1, which is 0.28. That means it's also satisfactory.
For the next compression member are 194 and 212. NED from the step pro analysis is 38.012 kN. From the calculated area, we can determine the UV section, which is 127 times 76 times 13. For sectional classification, we got both class 1. Then we got NCRD is more than NED, so it is okay. In buckling resistance of member, we have calculate in plane and out plane. Both in plane and out plane is satisfactory because NBZRD and NBYRD is more than NED.
I want to explain compression member at 192 and 210. NED value from step pro analysis is 36.801 kN. After determine the value of error, we get the value is 133.82 mm square. So the size of column that we use is 127, 76 and 13 with area 1650 mm. Sectional classification. Overall class of the section is class 1. The value of NCRD is bigger than NED, which is the value of NCRD is 453.8 kN. In plan, the buckling length is 3.47 meter. After calculation, the value of exact is less than 1, so it is okay. The value of NED over NBZRD is 0.47, which is less than 1, so it is satisfactory. For out plan, the buckling length is 3.85 meter. Value of NCRY is 661.39 kN. The slenderness is 0.83. After calculation, we got the value of XY is 0.23, which is less than 1, and it is okay. Value of NBZRD is 104.36 kN. Of NED over NBZRD is 0.35, which is less than 1, and it is satisfactory.
For the compression member of 193 and 211, the NED value from the step pro analysis is 38.018 kN. Then the design must satisfy the following formula, which is NED over NCRD is lesser than 1.0, value of cross-sectional area which is 138.25 mm square. Then we decide to use the size of UB which is 127 times 76 times 30 and the area is 1650 mm. For the sectional classification, we got the value of 0.92 and for web, the calculated value is 24.2 which is lesser than theoretical value which is 30.36. So the web is class 1. As for the flange, the calculated value is 3.74 which is lesser than theoretical value which is 8.28 and the flange is class 1. Therefore, overall class of section is class 1. Next, for resistance of cross section, the NCRD value is 453.75 kN which is bigger than 38.018 kN, so the value is accepted. Next is buckling resistance of member for in plane. The buckling length is equal to 3.47 meter and for the NCRZ the value is 95.88 kN. For the slenderness, the value is 2.18. For the buckling curve, we're using the alpha of 0.34 and the value is 3.21. From the value, we get to calculate the value of NED over NBZRD which is 38.018 over 81.68. We get the value of 0.47 which is lesser than 1, so it is accepted. Next, for the outplane, the buckling length is equal to 3.75 meter. The elastic critical force is equal to 697.14 kN. The slenderness is equal to 0.81. For the buckling curve, we use the alpha value of 0.21. So from the calculation, we get the value of NED over NBZRD is equal to 0.11, which is lesser than 1.0, so it is accepted. For the connection design between members, we use the dimension of 2 north 65 times 50 times 6 mm and the P is equal to 400 kN. The steel grade is 275. For the FWRD, we get the value of 200 kN and we use the size of 8 mm fillet weld. For the throat thickness, is equal to 5.6 mm. For the shear strength of weld, the value is 222.75 Newton millimeter per millimeter square. For the minimum length required is equal to 160 mm. Next is the weld length may be arranged in two ways, which is the first one is balance the weld on each side. For the first side, the required length is equal to 1 to 5 mm, and for the other sides, the required length is equal to 70 mm. For the other ways, the weld placed across the end of the angle. The total required length of weld is equal to 160 mm. For L1, we get the value of 50 mm, and for L2, we get the value of 80 mm. For total resistance of weld, the value is 443.75, which is larger than 200 kN, so it is satisfactory.
Conclusion, the choice of the truss structural component is important since it may impact how well the entire building will function. As a result, the selected and suggested size are safe and cost-effective to use since they can sustain the load from the internal forces calculated. Lastly, the overall design for critical tension and compression members must be correct and the size chosen must be affordable for usage in the construction industry. Thank you.